In this video, we will talk about probability function for discrete variables, density function for continuous variables, distribution function or cumulative probability, and function probability calculations in general. The random variables are discrete and continuous variables. For discrete, we use graphs, tables, and formulas that give each possible value its probability. These probabilities always go from 0 to 1 and the total sum equals 1. The distributions for discrete variables are Bernoulli, binomial, geometric, negative binomial, hypergeometric, and Poisson.
Continuous variables are the ones that can take on any value in a certain range. Individual values have no measurable probability associated since they measure the area below the curve. The types of these distributions we can find are uniform, gamma, exponential, chi-square, Weibull, and normal.
Probability function discrete variables. Here we can see the different functions for each distribution, and also that each distribution function can have between 1, 2, or 3 parameters.
Here we have an example for discrete variables and its probability function. In this table we show the values for y, which are from 0 to 4, and the probabilities to each individual value. For the probability function we have this graph, where the y-axis shows the probability for the y value. Here we have an example. When y equals 2, its probability will be 0.2, and its cumulative function.
Cumulative function. In order to build this type of function, we just need to add the probabilities. First, we start at 0, that is represented at this point. Then we add 1/8 plus 0, it will give us 1/8. It is this value over here. Then for the third value, we just add the previous probability plus 1/4, so it will give us 3/8. And for the next probability, it will be 3/8 plus 3/8, 3/4. Finally, the last probability plus the cumulative probability, it will give us 1. This 1, we always have to reach to this value because it represents 100% of the total probability.
Here we can see the probability functions for continuous variables. We can also see that each probability function have their own parameters.
This uniform distribution. In the x-axis we find the values that can take the y, and in the y-axis we have the probabilities that we're gonna find for each value of the x-axis. For this example, we have the density function of a uniform distribution. Here's the equation we decided and the values we took for this graph. The probabilities for the values between 1.5 and 2 would be the area between these values and the line, which would give us 0.5 multiplied by 0.5, and the probability would be 0.25. Here we have a straight line, and then when we make the integer of this one, then we get the cumulative function of the same graph.
The graphic for the cumulative function represents the cumulative probability distribution, and the area under the curve represents the probability for a selected data.